Hello and welcome to my first ever video solution for a step question. This one was the one I posed to you about 2 or 3 weeks ago. It's from the 2005 paper, question 3. So have a good look at that, and perhaps you might want to jot down the first part if you haven't already attempted it. And I'm going to go through it together, and I'm going to point out some of the things that you should appreciate, which perhaps you don't do at the moment. In this question, A and B are distinct, so they're different numbers. Non-zero real numbers, so no imaginary stuff going on, and C is a real number too. Okay, so no i's in this. Alright, so we've got to show that if A and B are either both positive or both negative, then the equation, etc., has two distinct real solutions. Alright. So, probably the easiest approach is to solve the equation to get x, and I'm hoping that we're going to find it's going to be something that can only have two distinct solutions. Is this the only way we could solve this? No, it's not. We could also do this by considering the discriminant, but we'll do that probably in part 2. Lastly, I'm going to mention this again later on in the video, but I must plead with you that you must explain clearly why there are two solutions if A and B are both positive. It might seem obvious to you, but you need to write down the reason. Okay, so let's get started, shall we? I'm going to lay this out so that you can see it, hopefully. And here we go for the first part. A few things to point out. You can see that I've put equal signs aligned and only one per line. Okay, that's it looks really good, but it's also standard practice. Please also don't forget to write the plus and the minus. Alright. Okay, so once we've got that done, let's get to I mentioned that already. We have to write a conclusion. So what should we write as that conclusion? Well, I think you need to have something along the lines that for the square root to give real solutions, so we want a proper square root, no i's, okay? A, B must be positive, and there's two ways A and B can be positive. A and B could both be positive themselves, or they could both be negative, but you couldn't have a mixture. And so you just say something like that, and I think I've written down for you in the next slide. Oh no, I haven't. Okay, but something like that. So if you want me to spell that out again, say for the square root to give real solutions, A, B must be positive, so A and B need to be both positive or both negative, no other way. Okay, so let's go to part 2. And we can, we're told that show that if C does not equal 1, the equation blah 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 has exactly one real solution. Okay, as soon as I see this explanation of that, you've got to start thinking about looking for clues. Okay, and there's a really big one there when it says one real solution. As soon as people start talking about 0, 1 or 2 real solutions, you need to be thinking about the discriminant. That is that b squared is equal to 4ac for one real solution. Okay, so once you got that into your head that we need to do that, we need to find the discriminant. Clearly we want to tidy that question 2 up so that we can start to organize it into the shape of a quadratic polynomial, and therefore we can create a b squared and a 4 and an a and a c. So let's have a look at that, shall we? You can see I've multiplied through by x minus a, x minus b, and expanded the brackets, and I've ended up with this mess. Clearly I could put that all back and take it back to the question, which is why I've used the double-headed arrow there. Okay, this implies this, but this also implies that. Okay, which explains that sign. The equal signs are still aligned, and now I can group the x squareds, the x's and the numbers and coefficients. And so here we go: c minus 1 x squared minus c a plus b x plus ab bracket c plus 1 close bracket equals 0. Now I have a b, and I can square that. I've got a 4, I've got an a, and I've got a c. I am now in a position to find how many real solutions this can have. We're looking for 1, aren't we? So hopefully you're going to use b squared equals 4ac, and here it is if you did that. So we have the b squared, one of the signs gone away, and we've got it equals 4ac, so I've taken away 4 AC's. Tidy it up and you end up almost with, I haven't quite finished off the last one, sorry. C squared is equal to minus 4ab all over a minus b squared. Okay, so that was quite fun really. And moving on to the next part. Oh no, not yet. Shall we just discuss what that might entail? Have we done anything? Yeah, I've introduced you to a few signs, haven't I? That double-headed arrow. And I hope you're happy why b squared has to equal 4ac. If you think about your curve, if b squared equals 4ac, then in your quadratic formula, part of it just falls out and we're left with the solution minus b all over 2a, aren't we? That's just the one solution. Alright, so getting on to part, the last part, part 3. They gave us quite a tricky problem. They wanted us to rewrite the question, and there was a clue even in this. As soon as you see the number 1, well, we know that 1 can be written as a minus b squared over a minus b all squared. So that's how to introduce that. It might be that you find it having an extra line of working might make it more obvious for you, but we've basically got a difference of 2 squares, and I've written it up there. And so with a little bit of playing around, I don't think that's going to cause you too much trouble to obtain that result. But now again, you must conclude, what have you achieved by this? Well, you can see a couple of things. First of all, I hope you agree that a plus b over a minus b all squared has to be a positive number. And if it's a positive number, we can see that 1 take away any number is going to have a maximum value of 1. So c squared is never going to be a number bigger than 1. Okay, so that's important. Yeah, so that's my first conclusion. And I'll write it up for you neatly here. I am answering the question. Here we go. So that's what I conclude first, but that's not where we have to stop, because we can conclude even more than that. We know what c squared must be less than, but do we know what c squared must be greater than? And the answer to that question is yes, because if we consider what happens if c squared equals 0, well, that would mean that minus 4ab has to equal 0. And if minus 4ab equals 0, then either a or b have to equal 0, but we're told at the very beginning of the question that a and b are non-zero. So c squared is going to have to be greater than 0, and I've written it for you there. Okay, so I hope you enjoyed that question. As questions go, that's not too bad. It's a step 1 question though, so it's a good level, better than the A level, and if you can do that now, then you're in a very, very good place. Okay, I'll probably send you another one of these next week. Hope you enjoyed that. Cheerio.